good morning. Happy Saturday to everyone. We survived our first week of distance learning. Oh, Naya's taking a marker. Or remote learning for so many of us. And I actually looked at Time magazine this morning and found out that 87% of school children around the world had their schools closed as part of this pandemic. So that is an epic amount of children who are now forced not to go to schools. They cannot go into their physical school buildings. There's 1.5 billion. For most of us on right now, we have the luxury of getting schooling done online using technology, but it was almost heartbreaking to think of all the children who, if you don't have internet access, or what if there are multiple kids in a house and you're all sharing a TV screen or sharing that one laptop, that one phone, how much limited access there is for so many of us. So this epidemic is really showing a lot of inequity. So it just made me ponder and think about some things and how we can continue to help and share in any way possible. And so I want to continue using some of these resources that I have. So with that said, I did figure out what our problem was yesterday. I created a group for math tutoring mini lessons. I have it up there. And if you want, you can join that group. That will help you if you want to just see more videos live. I know many of my friends have lots of things. Not everyone has children or necessarily needs support here, but I want to make sure it's available to everyone. And if you're really looking for specific math tutoring, you please join the group. At the same time, on my YouTube page, you can just search for my name, Sarah Fuentes, or as my little kids used to have a hard time with my last name, so sometimes it was Fontes, Fuentastic. I've heard so many different versions of my name and spellings. But if you look up Sarah Fuentes, you'll see my face. And if you look for the one with lots of videos, I have different topics there that I've done for middle schoolers. And I'm actually going to do a new video today using Desmos to look at what happens with graphs when we make changes to the slope or to the y-intercept. So look out for that coming out later today. I'll post it in both the group and on my page. And there are 2 sites that I was thinking about for parents, especially if you're looking for practice for your kids. Here's a free one. You can go to math-drills.com. This is where honestly so many teachers who are tired of making up problems, we just go online. And we go to sites like this, and there are free worksheets, tons of worksheets for free, and answer keys so that we can get some more practice. So if you're worried that your kid doesn't have enough practice in a skill and you want them to work on something, simply go to that site and you can just type in the topic you want. It's math literally from K all the way up, and it will give you some problems, worksheets, about 10 problems on it. I like using those a lot. And finally, since we are going to do some graphing today, if you do not have a graphing calculator, which is me, I didn't have one. When I was in school, in high school, I had to borrow one from the school, and I was lucky enough to have a school that would give me one. But I can just imagine so many kids who don't even have that available in their schools. So you can use a site called Desmos, DESMOS.com. They also have a great app that you can use right on your phone. So I have it in my calculator app. And this helps you, is you can put in plug in an equation, a point, a line, and it'll graph it right there. It has tons of functions you can put on it, and I like using that as well. So you don't have to actually buy a TI-82 graphing calculator when we have one available for free online. Okay, so with that said, since we found yesterday's video, and I'm so grateful we did, I'm only going to really cover 2 topics a little bit more. I'm going to do a deep dive. So let's zoom out for a little bit. We're going to look at simplifying fractions. I'm going to look at 3 different ways you can do that, 3 different levels. Depending on where you are, you can absolutely do this. And then we're going to talk a little bit more about graphing equations using 2 different strategies. So I'm going to start with those 2 to just start off. Okay. Alrighty then, let's go and jump right in. We're going to do simplifying, and I'm going to start with what if we're at the lowest level and we get a fraction like this, 6/8, very simple and easy, but we're not sure how to find an equivalent fraction that's smaller. If we wanted bigger fractions, I would tell kids, oh, if you want things to get bigger, I would just skip count. So 6, 12, 18, 24, and then keep going over here, 8, 16, 24, 32, and each of these is equivalent, but there are actually some more hidden ones because this is not in simplest form. I can actually simplify that. So one way I tell kids to do in the very beginning is to think about 6 and 8. And we're going to try and make some common factors. We're going to think of factor pairs. Factor pairs are two numbers. When we multiply them together, make this original number. And we always start with the easiest factor pair, which is just 1 and that number, 1 and 6. I like to start with a smaller number first and then go to the bigger one because sometimes it just pops out. And then I just start thinking in my head, what are some other factor pairs that I know? It's even, so I know 2 times something makes 6. And then I can just think of my division, how many 2s make 6? 3. And then something interesting happens here. The next number that I would use is 3, because notice these are kind of ascending, but I already have 3. So this tells me I can stop. Like when these 2 pairs get very close together, I can stop. So same thing with 8, I can do 1 times 8. I can definitely do 2 times 4. And I can try and think, is 3 a factor? No, 3, 6, 9. Nope, skips over, so 3 doesn't work. Next number will be 4. And I already have it, so I'm already done. So then all I have to do again is look. Use your eyes to really, really just look. Most of math is just being observant and being able to look and see with your eyes what's going on and start thinking about patterns. And just by looking here, we can see that our common factor is 2. Okay? That means I can reduce this number by 2. So yesterday we talked a lot about using multiplication to make an equivalent fraction. This time we're going to use that same number. We're still going to use a property of 1. So I'm still going to use 2 over 2. So think property of 1, prop 1, and I can simplify both to get 3/4. This is the number in its simplest form. That means 3/4 is also equivalent to these numbers. And then if I was counting by 3, so what was I missing? 3, 6, I was missing 9 over 4, 8, 12. That's an equivalent one. 15 over 20. So you can see how just because I didn't use the simplest fraction, all these other fractions kind of just pop out. So good to know. This is how we can just jump in with equivalent fractions. So that's how I would use this. Is called my factor pairs to find an equivalent, to find the greatest common factor. I'm just looking to see. But what if my numbers were a little bit more complicated? Because these are low level. This is where I would say maybe 3rd, 4th grade is using a number like 6/8 to simplify. But what if I was using a number like 48 and 72? You can still use, if you wanted to, you could go and start listing factors, okay? And I'm thinking logic. 2 times 24. Does 3 go into this number? And I actually know it does because I have a little trick for 3s. My trick for 3s is if the numbers add up to 3, 6, or 9, I know it can be divided by 3. So like this, 4 plus 8 is 12. And I know 1 plus 2 makes 3. So I absolutely know that I can divide this number by 3. And it does work. 3 goes into 48 16 times. This also works with 9s. The digits always add up to 9. And that's how I used to tell my kids, 9, 9, 9. It all adds up to 9. And I would take any number and it would do it. So think of your 9 times tables. 0 plus 9, 1 plus 8 is 9. 2 plus 7 is 9, 3 plus 6 is 9. You can keep going. 45, 54, 63, 72, 81, 90. They all add up to 9. And even if you went, well, what about 99, Sarah? Well, okay, so that equals 18, and 1 plus 8 is still 9. So it's a pattern that I just saw. Because again, remember, most of this is your mind seeing patterns and recognizing sequences and patterns and just opening your eyes to noticing those things. And I saw this when I was a little kid and saw that 3s and 9s always work. Just like most kids recognize the 5 times tables, they always end in 5 or 0. So I use those 3 facts to always know if a number is divisible. Let's see, 2 if it's even, 3 adds to 3, 6, 9. 5s are easy, it's either 0 or 5. 9 9, 10, ends in 0. So I use this. This is all I really use when I'm simplifying. And it tells me a lot about numbers. Okay, so I'm going to keep on going just for sake of time. 4 times 12, I know that works. 5 doesn't work because it doesn't end in 5 or 0. 6 does work. 6 times 8. And 7, I know 7 times 7 is 49, so that doesn't work either. The next number would be 8, which I already have, so I'm done. So again, that's how I think through my factors. I like going in order from 1 up until these two numbers get very, very close together. And then when it repeats, I know I have every factor. But I use these math facts to kind of help me. Same thing with 72, because this is a harder number. 1 times 72. It's definitely even, so I know 2 goes into something. 35, 36. 7 plus 2 is 9, so yep, 3 works. 3 goes into 7 2 times, 12, 24 times. So 4, does 4 work for this? I'm going to check to see if it does. I think it does. 4, yep, 32, so that's 8, so 4 times 18. Again, notice these numbers get bigger, these numbers get smaller. So I'm getting closer because the gap is getting smaller. 5 doesn't work. Oops, I think the mailman is outside. Yeah, Naya's barking the dogs. That must be the mailman. She's not friends with him. 6, especially because I noticed like 18 definitely is a factor, has 6 as a factor, so I know 6 is going to work. 6 times 12. 7 doesn't work because that's close to 70. 8, does 8 work? Yes, 8 works. 8 times 9, and boom, look how close I got it. So I'm actually done. And now I can just look to see what do they have in common. I like using my smaller list. They both had 1, they both had 2, they both have 3, they both have 4, 6. This one has 8, this one doesn't. All right, 9, oh, this does have 8. 9, no. 12, yes. 18, no. 24, yes. Okay, so then my highest factor is 24. So I'm going to use my same rule as before, property of 1. And I'm going to divide this by 24 over 24. Please do not say divide by 24 because then you're doing 24 over 1. And that's not mathematically correct. And my job is to make sure you're using proper math. And again, you don't have to think about this. How 48 divided by 24, I'm just going to go to my list, this 2. Because you already did the hard work. And 72 divided by 24 is 3. So even with a bigger number, this one I would say is probably 6th grade. You'll get a number like this. And you can see how I can still use a factor pairs to help this out. But I'm going to show you another way that could work because that was time consuming. And time is everything when you're getting older. So you could do this. And if you're at a stage where you feel comfortable with that, go ahead. Common Core math seems like it's very complicated and there's always a faster way, and it's really because we want to make sure that you really have the concept down until you're ready to get to that next level in your development in math. So I'm going to show you another way you can use, which is called prime factorization. And the key word there is prime. And we're going to make little factor trees for both. So watch what I'm going to do. I'm going to break down 48 and 72 into its prime factors, so I can't break it down anymore. And it doesn't matter how you want to break it down. So let's say I want to say 4 times 12. I can break this more. 2 times 2. So I can't break it anymore. So because it would just be 2 times 1, 2 times 1, 2 times 1. It goes on forever. So I'm going to leave it there. And I'm going to do the same thing with this. 3 times 4. You can pick any number. That's what I like about this. And 2 times 2. So my number sentence for 48, I have 2 times 2 times, I like to do it in order, 2 times 2 times 3. And I'm going to do the same thing with 72. I like 8 times 9. And then I could do 2 times 4. And 2 times 2. And 9 is just 3 times 3. Now watch this. All right, just so I have a little space there. I have 1, 2, 3 2s, 2, 2, 2, and 2 3s. 3, what do they have in common? I'm going to list every single time they have something, a pair in common. Well, here's a pair of twos. It's like playing Go Fish. Do you have a 2? I have a 2. Do you have another 2? I have another 2. Do you have another 2? Yeah, I have another 2. And do I have another 2? No. I have a 3. Do you have a 3? Yeah, I have a 3. And it doesn't even have to be the one underneath. I could just say, yep, I have a 3. And now there's nothing left because this has a 2 and this has a 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So my greatest common factor is 24. And I can just do the same thing. 48 divided by 72. 48 over 72. Divide by property of 1. I'm going to put a big one there so you remember that. And same thing. 2 over 3. So I can use this. I try to do this more with my older kids because they're ready to think about factors and prime factorization. And this is just another strategy. Feel free to use whatever you want. But this is just another way that a lot of kids like because you don't have to remember every single factor pair. And for some kids, I have 8th graders who I saw just 2 weeks ago in Queens who were trying to break down 2 numbers and they would mess up because they could not find the biggest factor because they couldn't remember all of them. And if your memory, if you don't have all that memorized, then this might be another way that for sure will help you. You just have to know what your prime numbers are. And as long as you know the prime numbers 2, 3, 7, and 11, you're good to go. And 13. And you're good to go because usually nothing has a bigger factor than 13 when we're doing middle school math. Okay? All right, so we have 2 ways right now. I hope you remember the first one and the second one. First one was just using factor pairs, and the second one is using a prime factorization. So my third way is just to use my math facts. So I'm just going to put the first way, factor pairs, factorization, and this one, I'm going to use my facts and I'm just going to keep breaking it down until I can't break it down anymore. So I'm going to just use what I know about these 2 numbers. And remember, I don't need to know every number. I just need to know a few. And just looking at this, I could break it down by 2s. I like to use 3s because they get a little bigger. So I do my little trick. 4 times 8. 4 plus 8. This is all I'm doing in my head. When I look at it, so you can see my thinking, I'm just doing 4 plus 8 equals 12. 1 plus 2 equals 3. Yes, I can use 3. And in my head, I'm doing the same thing. 7 plus 2 equals 9. So yes, I can use 3. And I'm just going to start reducing it by 3. So all I'm doing in my head, I'm just using what I know. And when I do that, I'm getting, let's see, 1 and 3 goes into 16 times. I'm going to do the same thing here. 3 goes into 7, 2, 24. Now I'm going to do the same thing here. Do I know any factors? Oh, now these are easier numbers. I know 4 works for both. And that's the trick. You just want to make it friendly until they're easy enough to use. And I can look here and I go, oh yeah, I can use 2. They're both even. So it doesn't have to be a one-step process at all. You can just use some of your math facts. And that will be the third way. So again, you're just thinking for yourself, what makes sense for you? What works for you in terms of where you are in your math process? This is more for kids who definitely know their math facts a little bit more than others. So those are just 3 ways you can use that. Okay. All right, so let's get ready to transition into some graphing. And I'm going to look at another way we can graph an equation. This came from Missouri yesterday. And then I'm going to review a little bit of what I did yesterday. Let's use these. Okay, so yesterday we started off with this equation, 2x plus 1, and we had to make a graph. Before we can graph, what you can do is just figure out what the points would be. And so you can just make a table for x and y. And you can just start putting in numbers. Like I like putting in numbers for x first and figuring out what the y would be. So what if x was 0? Okay. 2 times 0 plus 1 equals. So 2 times 0 is 0. 0 plus 1 is 1. So this would equal 1. Okay. What if x was 1? And I can just put in a few points to help that out. So what if it's 2 times 1 plus 1? 2 times 1 is 2. 2 plus 1 equals 3. All right. What if I have 2? 2 times 2 plus 1. 4 plus 1 is 5. All right. And this is enough for me to get going and start seeing a pattern that can start developing. So just by looking here, as I'm going up by ones, what's happening to my y's? My y's are increasing by 2 plus 2. So that means if I continue this pattern, my next number would be 7. All right, let's see if it's true. 2 times 3 plus 1, yep, 6 plus 1 is 7. So I definitely see something happening. As this is changing by 1, this is changing by 2. This is going up by 2. So remember when we talked about slope, we said slope is the change over y and the change over x. Okay, so my y's are going up by 2's and my x's are going up by 1's. So I know my slope is 2 over 1. Okay, my slope is 2 over 1. Ah, yeah, yesterday we talked about this. We said that this number here, this coefficient in front of the x, is my slope. So I can see how my chart will be changing. I know that my y is going to change by 2's because it says it right here. It's literally over here. I can see that it's going to go 2 over 1. I can see that that pattern is going to happen. As this goes up by 1, this is going up by 2. So, but if you don't see that, because remember it's where you are in your process, and not everyone sees things in the same way, I would just tell a kid, start graphing. So I don't have much graph paper left, but I saved some, just for you. And I'm going to try putting it a little bit higher. And what I would have a kid do in the beginning is, again, you can take these points and now you can just plot them. So 0, 1. So here's 0 up. 1. 1, 3. 1, 2, 3. 2, 5, 2, 1, 2, 1, 2, 3, 4, 5. And again, you're starting to see, notice that it's going up 2 over 1, up 2 over 1, up 2 over 1. So your brain is almost like a video game. Once you start seeing what's going to happen, your brain can start moving a little faster, but you have to train your brain to think about it and to see what's happening. And all I did was put these points up. And I knew that this was going to be the next one because I'm just following the pattern. I just know that that's what's happening linearly. And I would just use my straight edge, and boom, you have a line going directly up, up 2, that was silly, up 2 over 1. So my straight edge can go right through all of these points. Okay, so that's another way of graphing. If you're not sure, you can just make a chart because you're not sure what to do. And what you can probably do by this grade is you can absolutely do substitution. This is good for 7th and 8th grade. The other way I talked about yesterday was to just look again at what the graph is telling you, my M and my B. And remember, my B is telling me my Y intercept. It's pretty much telling me a point. When this number is 0, my B is that second number. So if you look here, this is telling me that when this is 0, my Y has, this number over here, this second term, has to be 1. That's going to be a point. So even if I gave you something like 3x plus 4, you already know your first point is 0, 4. And that's your intercept, if that makes sense. Okay? So I can see it there. And my next number on the side, this is just telling me slope. It's telling me how fast it's going. If it's a positive number, it's just telling me it's going up. If it's a negative number, like let's say this was -3, it's going to tell me my line is going down. The bigger this number gets, the faster it's moving up or down. So all I really have to do, let's say I'm plotting this one over here, -3x plus 4. All I would really do is know what is my first point. 0, 4. So 0, 1, 2, 3, 4. This is where I'm going to start. And this number is going to tell me how to move. This number is telling me that I'm going to go down 3 over 1. That's it. So I'm going to go down 1, 2, 3, and over 1. And there's my second point, 1, 1. And then it's going to tell me again to go down 3, 1, 2, 3, and over 1. So there's my next point, which is 2, -2. Okay? So that's just another way of graphing. I can use this, and it's almost just my map to tell me where to go in the problem. So it tells me my start, and then how to move. So if this is my starting position, where am I going to move next? Okay, it's kind of like in a game. If I'm playing volleyball, I know where I start, and then I know how my movement is going to go, and I can just draw the rest of the line to connect the points. And if I have to go backwards, then I know I'm just going to go, if I have to make a point to the left, I know I'm going to go up 3 and over 1. And I have that one too. So these are 2 other ways that you can use to actually graph equations. But you absolutely, here's my real CFS, which is my criteria for success. You have to have it in y equals mx plus b form. Have to have it in this form. Once you have it in that form, you can start with that set. So if I gave you an equation that looks like 3x plus 4y equals 10, that's not y equals mx plus b form. You're going to have to move this over. You have to use now some of your other skills. -3x plus 10. Still not, there's y, and then there's an mx, but this 4 doesn't work. I have to divide everything by 4. Okay, and now now it's in a form that I can graph. I know, and you could probably turn this into a whole number, 2.5, because I don't want to use that number right now. 2.5. And that tells me where to start at 0, 2.5. And this is telling me how to move. Down 3 over 4. Down 3 over 4. That's all it's telling me. Down 3 over 4. And I got my line. If you don't like doing it that way, you can just make a table. And just put in, well, what happens when x is 0? Or what happens when y is 0? If you want to put those points in, just plot them in. What happens when this number is 0? What happens when this number is 0? And then just give some more points in there, and you can see what happens. So that is our work today. Wow, we had a solid half hour just on 2 topics. Definitely doing a deeper dive into different strategies. I hope you found this really useful. And as always, next week is the start of a brand new week of distance learning. So we have 1 more full week to go. I know this is hard, and it may be for like, pulling your hair out because it's so hard and challenging to do, but I guarantee you I am here to help you, and so are so many other teachers. But I want to make sure that I can be used to as many families as possible, just be of use. So if you have more questions, feel free to add pictures of problems in the comments. Let me know, Sarah, can you work on this topic? I've taught every grade from 2 all the way to 8, and I'm even coaching a 9th grade algebra team for 2 years in a row, so I can even cover 9th grade algebra. Just give me topics, and I'm more than happy to spend some time and supporting, and I can take some of your own questions, and put them up here and use them for modeling. I think I'm going to also put up, besides adding to the group, math tutoring mini lessons, I think I'm going to put some more videos up on YouTube as well. So if you really want a deeper dive into a topic, just please let me know. Or just say, hey, I really need some support here, and I can also post some videos. And my final, I have a huge big idea. I'm actually working on some math work, or some courses for 6th grade, and I am looking for 6th grade families. If your kid is in 6th grade, please hear me out. If you know someone who's in 6th grade, please ask them to get in contact with me. I'm putting something together specifically for 6th grade families, and I want some ideas, some coursework ideas and thoughts, starting with geometry, and I would love to test some of the materials out with 6th grade families in the beginning. So all you have to do is either message me, hit me up on Messenger, put a comment in the bottom, let me know you are interested, or you can even email me. Oh, that's what I didn't put. You can email me at Sarah@Math Mini Lessons. Let me put it up here. My board is getting so messy. Sarah@MathMini, this is all one word, lessons.com. Send me questions, thoughts, ideas. If you're interested in doing the 6th grade curriculum, you want to try it out, the things I'm putting together, some lessons, reach out to me and let me know. So as always, I hope you had a really great time today, and I will see you next week. Take care.